Hello and welcome back to another one of these A-level maths revision lessons. So today we're going through again statistics, and again we're breaking up the topics really nice and small so we don't get overwhelmed. In this instance, I guess, we're going to go through interpolation and standard deviation. Again, one of the trickier topics in kind of AS statistics, and it does come back in A2 too, as well. And so, what is interpolation? Well, if you think about the word, it kind of looks like extrapolation, right? And when you extrapolate, it means you go outside, that's what extra means, outside the data range in order to predict things. So you might continue a line of best fit, for example. So interpolation means inside, so we're actually going to go inside these values. And you're going to see exactly why, well, right now actually. So what we want to do here is, we want to add another column for cumulative frequency, okay? So we'll start with that. So again, that's going to be 7, then 17, then 32, then 51, and then 60. Okay, and this will just help us work out the median and work out what's going on exactly. So to work out the median normally, what we would do is we take the number of data that we have, which in this case is 60, and we half it. So we're looking for the 30th value. And again, this is just to explain exactly how or why we need interpolation. So if we look at the 30th value, it's going to be somewhere in this grouping here, right? Because we have 17 up to this point, then we have 32 up to this point. So somewhere in this boundary, within this class, is the median. Now the problem is, I can't say that the median is, for example, 165, because I don't know if it's midway through here, okay? However, we don't have the original data, so we can't actually work out the exact median, we have to work out an estimate for it. And it turns out that the best way to do an estimate is to assume a kind of normal distribution inside of the classes itself. So there's a few people at 160, a few people at 170, but most people are towards the middle. Okay? So not exactly in the middle, but towards the middle. And the way we do that is, first things first, you want to identify which class the median would be in, which is 160 to 170. So it's in the class 160, 170. Okay. And now here's where we're going to start. So we start off with 160 centimeters for our median. Okay. So all you do is you write the lower class width or class boundary. So lower . So I'm going to basically write out a formula for you. Then what you need to do is add on the extra stuff that we have. So when we go up to here, we get up to 17, right? But we want to get to 30. So we have 13 left over. So basically that tells us we want to go 13 spaces into 160 to 170, 13 data points into this class. Okay? And now we're going to estimate what those data points look like, as in what they're going to be. So we're going to plus 13. And again, where I got that is from the leftover amount. So all you're doing in this case is you're taking 30 and you're subtracting the cumulative frequency up to that point. So again, just as a quick go again. So the 30 comes from the 30th value. We're up to 17 here, and next is 32. So we've got 17 values, that's fine. We need 13 more values, okay, which is somewhere inside this class width here. And what we do is we divide it by the frequency of that class, 15. And again, that's the frequency of the class we're talking about. Put it in brackets. And then what we do is we times it by the class width. So in this case, the class width here is 160 to 170, so that's going to be a class width of 10, right? 170 minus 160. So let's think about what this formula is actually telling me, okay? Because this might seem a bit weird. What we're saying is we go up to the lowest class boundary, Okay, so 160 centimeters. And then we're adding on the fraction of whatever's left over, right? So we have 13 left over. That is going to be 13 over 15 into this boundary. 13 fifteenths into this class. We're looking for 13 fifteenths of this class width. Okay, so that's where this comes from. 13 fifteenths of the class width. And we can work that out. And again, you can use a calculator, of course. And we're going to give it to the nearest whole number because all of our data are to the nearest whole number. So we have 160 plus 13 over 15. Again, if you're not too sure about that, this is totally fine. We're going to do a few more questions and you should hopefully start seeing the pattern. So we have 168.666666. So we're going to round that to 3 significant figures. So first of all, I'm going to write 168.6 recurring. So that is equal to 169 centimeters to 3 significant figures. Again, remember to use your units. Okay, so what about an estimate for the mean? Well, the mean is a slightly trickier beast, okay? In order to work out the mean, here's the formula we're going to be using now that we are in A-levels. It is the sum, so remember this kind of symbol here, capital sigma, is sum of the frequencies times the midpoints. And we divide it by the sum of the frequencies. Okay. Now, because I have a bit of foresight, or again, you can call this n, by the way. So if you don't want to call it the sum of the frequencies, you can call it n. Okay, number of data is completely fine. Okay. Now, I'm going to work these out separately because, okay, spoiler warning, right? With standard deviation, we need to work out this again anyway. So it's a good kind of, it's a good practice or a good habit to have for you to work these out separately, because in every single, so this is like an actual exam question, right? Interpolation, then mean, then standard deviation, they do it all the time, okay? All the damn time. So what you want to do is when you work out the mean, work out this separately, and then you don't have to work it out twice. It saves you a few seconds in the exam, okay? So, sum of f of x, what is that going to equal? Well, the frequencies, and again, this is just the sum of all of them. So what I'm going to do is I'm going to take the frequency times by class width, plus frequency times by, midpoint, times plus frequency times by this. So the midpoints of all these are fairly self-explanatory, but we can add like a little column here, 145. If you're not sure how to work out a midpoint, you can just look for the middle number like I am, but that doesn't always work. Sometimes the class boundaries are very strange. All you do is you add the two numbers and divide them by 2. So 180 plus 200 is 380, and divide it by 2, and that will give you your answer. So that's completely wrong. That's 190. That's what I get for not reading the last one, yeah. So it's a good thing I checked by doing 180 plus 200 is 380, divided by 2 is 190, not 185. Is that correct? Yeah. Okay. So we have 7 times 145. If you're thinking this is tedious, it is 10 times 155. Now, I think there are some of you who are kind of wizards with a calculator and might be wondering why I'm not doing the where in the calculator. So keep in mind, doing it all on the calculator using the method, it's not the best practice, because keep in mind, if you've done anything wrong, you'll get 0 marks. At the moment, I'm at least getting method marks. So for those of you that don't know, on this standard Casio calculator, you have a which one is it? Table function on your calculator just by getting to menu. You can enter all of the data into a table and it will calculate the mean and standard deviation and everything else for you. But keep in mind, some mark schemes will say methods entirely done on a calculator are not accepted, so you get 0. Or if you've made a small mistake anywhere, and believe me, it's very easy to do, you'll get 0 because you have no method marks, because you've done no method. So you can do it, but you do it at your own risk. And again, I'd recommend checking a mark scheme for your relevant exam board if you're unsure if you're allowed to do it or not. But again, many exam boards do this topic. Okay. So I worked this out, and again, the reason why I worked it out the long way is because I know for a fact that I'm going to use this in the next part. That just comes from experience. So what we can do is 7 times 145. Again, I can normally type this a lot faster when I'm on an actual calculator, but and that gives me 10,075. I can read, I promise. So then my mean is just going to be 10,075 over 60. Again, answer. So let's call it 168 to 3 significant figures. So I'll write out the full, not the full number, which is equal to 168 centimeters to 3 sig fig. Perfect. Again, if someone starts telling you their height and starts giving you like 3 decimal answers, then you should run away. Okay, standard deviation. So this is a new one that you probably haven't really come across before. So the standard deviation is basically a measure of how far the data is away from the mean on average. Okay, so if we look here, our mean is 168. So it's, let's say in this class, right? Now, the standard deviation is a measure of spread. This is an important thing you need to know, okay? Because, again, you're going to be using use spread and you use average in order to kind of compare data sets, right? So you need to know what things are measures of spread. So you have the range, which we don't use anymore in A-level because it's babies. Interquartile range, which is used for box plots. And now we have standard deviation, which is another measure of spread. The smaller the standard deviation, the smaller the spread. Think about the word, right? Deviation means how far you're away from the normal, right? And standard means average. So standardized testing, for example, is average testing. It's when you grade to a curve, to an average. So standard deviation is a measure of how far away data points are from the mean on average. Okay? So the more spread out the data, the bigger the standard deviation. The less spread out the data, the lower the standard deviation. Okay? Bigger number, more spread. Now to work out the standard deviation, here is the formula. It's given a lowercase sigma as a letter. And again, not all exam boards actually give you the formula. And there is a huge mistake that people make. They say these two things are the same. They're not, okay? Sum of f of x is what we worked out here. Sum of f of x squared is not this number squared, okay? It's completely different. The sum of f of x squared would be 7 times 145 squared. You squared just the 145, okay? So that's a very key thing. So we need to actually work this out separately. And it's going to give us a different number to just 10,075 squared. So be really careful with that. They're not the same thing. Again, lots of people make that mistake. And unfortunately I actually deleted my... So if you aren't an idiot like I am, you can actually just go back through your calculator and square the answers. And as in square the x values. In fact, I'm pretty sure you can actually get it back. So, actually no, because I pressed answer divide, right? Oh, there we are. There we are. So if you press off on the calculator, it does do that. I was hoping it did. So squared. Squared. Cool. And as you can see, it doesn't give me this squared. Okay. Never mind, I put that comma in the wrong place. 1.7 million. Cool. So now we can actually put this into our formula. So sum of f of x squared is 1702,575 over 60 minus 10,075 over 60 squared. Again, super easy to make a mistake. Okay, so let's try and be smart about this. Answer. Whoops. Okay. That gives me 13.4 to 3 significant figures. Whew. Okay. Hopefully that makes some amount of sense. You can technically give this units. The units would be the same as centimeters, because what they're basically saying, so if you want you can give it units of centimeters, is that on average, so most of the data points are within 13.4 centimeters of 168 centimeters. That's where most of the data is. Not all of it, but most of it. Okay, so hopefully that makes sense. That took us quite some time. So we'll go through another example. Again, we'll do it nice and slow. There's no rush. We can just keep taking our time. And again, once you start getting good at this, you'll be able to just hammer it out very, very quickly. So again, use linear interpolation to estimate the median of the coded times. So I'm going to add a little cumulative frequency. And again, to make sure we're doing it right, it says there's a random sample of 50 employees, which means our cumulative frequency should eventually add up to 50. Plus 14, so it'd be 39, it'd be 43 and 50. Cool, so it looks like we've done it right. Okay. Linear interpolation. So again, let's go down A, and we're going to do n over 2, which is 50 over 2. We're looking for the 25th value. So the 25th value is going to be within, so 1, 10, 29, so it's going to be within this class here, 10 to 15, okay? So we know it's in that class. So what we do, again, if you remember the formula, we take the lower class boundary, 10, we plus what's left. So we want to get to 25, and we only managed to get through 10. So 25 minus 10 gives me 15. And we divide it by the frequency inside that class, which is 19. So we're 15/19ths of the way inside of that class. And the class width is 5. And we get 13.9. I'm going to do it to 3SF. Okay. And the reason why I'm doing that is it's time in minutes. We can give decimal for minutes, that's fine. So we don't normally go to like 2 or 3 decimal places, so I'm going to leave it like that. Okay. And that's the median of the coded times. Perfect. For part B. Estimate the standard deviation of the coded times. Okay, so standard deviation, you know what we need to do. We have to do sum of fx and then sum of fx squared as well. So again, if you want, we can write out the midpoints. 2.5. So 15 plus 25 is 40, divided by 2 is 20. And 25 plus 40 is 65, divided by 2 is 32.5. Okay, so let's go. Again, might be tedious, might be mind-numbing, but you only have to do this once in each exam paper. So hopefully that gives you some level of comfort. I just realised I put the frequency second. That kind of bugs me. Should I change it? No, I'm not going to change it now. 77.5 times, I think that was 9. Plus 12.5 times 19. 20 times 14. 32.5 times 7. What does that equal? And so technically speaking, if you want to be lazy, which I do, I can also work out sum of f of x squared without writing out everything by just doing it on the calculator, which you know would be fine as well. 2.5 times 1. I mean, have mercy on me, right? Plus 7.5 times 9. Okay, that is 815, perfect. Now again, to work out sum of f of x squared, all I'm doing is squaring the... Now I need to be careful, because it was the second number before, but because I'm an idiot and I wrote it first, it's actually going to be the first number. So yeah, be super careful which one is actually your midpoint. You need to be squaring the midpoint, nothing else. So be really careful. Or just stick to an actual convention when you say it, unlike me. Okay, and then again we've used the standard deviation formula, but I'll write it out one more time for you guys. So sum of f of x squared over n minus sum of fx over n squared. So if we sub that in now, we get square root. The answer button is going to be what that is. N is 50 minus, whoops, bracket, crap, right. Bracket fraction, sum of f of x 815 over 50, close bracket, all squared. And you should get 7.988, so we could call that 8.0. Actually, no. We will need to make sure it's accurate, actually. Okay. Whew. So, for part C, the coded data was calculated using this formula. So this one here. So what they've done is they've taken every single piece of data, every single one, and they've subtracted 20 from it and then halved it. So all of the information we just worked out now was actually for the wrong thing, so to speak. So they've subtracted 20 and halved it. So if I rearrange this, right, so I get 2x, I can get back to the real data by doing this, okay? Which is exactly what I want to do. I want to find out what the standard deviation and median of t is. Now, here's where things get a bit more interesting, okay? Now, the median and mean, you can just sub straight into this formula, okay? So, median and mean, sub straight in, okay? So once you have your equation for uncoding the data, all you need to do, so again, this is for the median, and if the question said mean, then we'll just do the mean the same way, okay? Don't worry about it. Then the median for t is just going to be 2 times the median of x, 13.9, plus 20. Okay? Just like that. 47.8. Nice and easy. Now, this works for the mean as well. Now, here's the key thing, about the standard deviation. It's only affected by times or divide. Okay? Now, I'm going to try and give you an example. If I add 20 to all data values, right, the average distance from each other doesn't change, right? So let's say we have 1, 2, and now I'm going to add 10, okay? Now, hopefully you can see that the mean and the median will change, right? The median is now 13 and it was 3, and the mean is going to be 13 instead of 3. So it does change, hence we need to include it in our calculation. Now the standard deviation, let me ask you this, okay? It's a measure of spread. Has the data become more spread out? If I do 5 minus 1 here, I get 4. If I do 15 minus 11, I get 4. The standard deviation is not affected by adding or subtracting. And now, if instead I timesed by 2, then the spread does change, right? I'd get 2, 4, 6, 8, 10. Now the range is 10 minus 2, 8 instead of 4. It's doubled. So all you need to do is actually do the timesing. So in this case, since they halved my data, I need to double the standard deviation. That's it. I don't need to add the 20 because adding and subtracting numbers does not affect standard deviation. It doesn't affect spread. It only affects the mean and median, the average, okay? So, in this question is going to be 7.99 times 2, which would be 14.98. No, 15.98. Okay. Hopefully, wait, am I being stupid? No, 15.98 is correct. Cool. I hope that makes sense. Hopefully. Next question, next two questions are a bit more fairly similar. However, check this out. Sometimes, if you pray hard enough, the gods of Edexcel and Ofqual will listen to you, and they will sometimes give you these values in the exam, in which case you don't have to work them out, and it makes these bits a bit faster. And to be honest, I personally think they should give you it because there's no real reason not to have it. Okay, so let's again get back to it. We want a cumulative frequency column. So we have 4, 23, 64, 90, 99, 100, which again matches the 100 people here, so we know we're correct. And again, it's important to check that because there are people that have actually made mistakes in this, and myself included. The thing is, if you make a mistake, that's fine, if you can spot it. So make sure you check if they've given you the actual total. If they have, then you're in luck. You can just quickly double check it and you'll be fine. But make sure you do double check. Use linear interpolation, where we're going to do the exact same thing we did before. What we're going to do is, for the median, we do this time 100 over 2. We're looking for the 50th value, which we can see is in this class here, which is in the 20 to 29 class. There's actually something else we need to do. Okay, now when I look at distance, that is continuous data, right? It doesn't have like half numbers in it. So we need to actually make sure we add these boundaries. There has to be an overlap. We cannot allow it to not have an overlap. Okay? So you always just take half away, add half. So these are our new class boundaries, okay? Class widths. Technically you don't need to do this one, but I'm going to because it'll make our life a bit easier later on. Okay. Now you might see why I actually spotted this right away. Well, not right away, but when I did this, because again, 50th value is in this class. The first part of the linear interpolation formula is taking the lower class boundary. It ain't 20, it's 19.5. So then you plus how many we had left. So we got up to 23, we want to get to 50, so that's 27 left over. And the frequency inside that class is 41. And you times that by the class width, so 29.5 minus 19.5, which is 10. So again, if you look, a couple things changed here, right? The class width here is 10, but here it's 29 minus 20, which some people would write as 9, when if it's including 29 it should be 10. So yeah, be really careful of that. If you don't have continuous data, it's just like in the histogram video, don't have continuous, if you have gaps between your boundaries and you have continuous data, make sure you add those extra class widths. So 19.5 plus open bracket 27 over 41 multiplied by 10. I did that in the least efficient way possible. And you get 26.1 to 3 significant figures. Is that a reasonable thing? Yeah, it's miles. We don't want to go too deep into miles. Okay, estimate the mean height. Well, again, with the mean. By the way, the mean is sometimes given the whatever the variable is, which they didn't give us one, so maybe x or something, with a little hat on it. Just FYI. It's the sum of fx over n. So 2651 over 100. So 26.51 miles. Yeah. So it didn't round it, so I'm not going to write that. And then lastly, estimate the standard deviation. Again, so can you see how quickly how quick these questions can be once they give you the values? Okay, so again, in more of the recent exam papers, they've given you the values, which is an absolute blessing. But again, they don't have to, which is, fun. So again, this is the sum of f of x squared over n, which is 100, minus the sum of f of x over n squared. So if you notice, all you do is you're just taking away the mean squared, right? So what will that give you? Let's have a look-see. So if you wanted, you can actually write minus this answer squared for this bit, so I'll show you. Great. And technically speaking, I could just do minus answer squared, because this thing here, the sum of fx over n squared, is just the mean squared. And that gives me the right answer. But you don't have to do it that way if you don't want to. Okay. And that gives me 11.1. So the mean is 26.51 miles with an average deviation of 11 miles. And that's it. So we did a 6 marker in a couple of minutes. I don't think we took that long. I think we took about 4 minutes, 3 or 4 minutes. So you can really scrape together these marks. So, what about this one? This one becomes slightly different. Hopefully you can see what the difference is. It's not grouped data. Okay, this is just the times. Okay, so you need to be able to do standard deviation and mean and everything when you just have like normal, regular, run-of-the-mill data. Okay, not grouped, and it's continuous. So the mean time taken, I'm hoping this is fairly self-explanatory. All you need to do is, so for the mean, what you're doing is you're doing the sum of just x in this case over n. I want to work out the sum of x because again I can see the standard deviation bit. Just as a bit of a word of warning, you're always, if you have mean, you're going to work out the standard deviation afterwards. So with practice, all you need to do is add up all of these numbers. So 45.2 plus 46.9 plus 46.1 plus 46.2, 45 0.4, 45.1. Also, for those of you that want to use like just the table method, keep in mind that entering something into a table generally takes about as long as just working it out. I almost lost my place there for a second, I was going to cry. 46.4 and 45.7. Good lord. And, oh, I didn't show you the answer, it's 551.8. While we're here, I'm actually going to work out the sum of x squared, which we need for the standard deviation, because I really don't want to enter this again. So keep in mind, it's not just this squared, okay? It's not going to be the same thing. So, essentially, if you add up a bunch of... It's like Pythagoras' theorem, right? If you square and then add numbers, you get a different value to if you just add them and then square them afterwards, like square the answer. So please keep that in mind when you're doing this. You can't just square the value, like the overall number. It will not be correct, okay? Again, think of Pythagoras. A squared plus b squared is not equal to a plus b all squared. And that gives you 25,380.38. Okay, so with the mean, we just do that and we just divide it by the number we have, the number of data points we have, which is 12 in this case. So again, I think this would be the first topic that might give you a slight challenge that we've done in statistics so far. Again, if you guys think I should like speed it up, then let me know, because I know you guys have got exams approaching. 45 point, I want to call 9.8 because I don't want to round it too much. But I think taking the slower approach is actually better, because at least then you're getting through it. But this is probably the first slightly difficult topic. I do mean slightly. But it can still catch people out. So again, the lesson after next. So the next lesson is regression, which again, people find very tricky. The lesson after that is when we're starting to do probability, specifically with the binomial distribution, which people find extremely tricky. And then we're going to do hypothesis testing, which people find even worse. So, standard deviation, if you don't have any kind of classes, it looks pretty much identical. If you don't have a class width, a class boundary, so a midpoint, then you just don't have the midpoint in here. So it's basically the same equation, okay? So subbing those in, that's our answer. Square root, I don't know why I looked over there, 25,380.38 over 14 minus 551.8. 16.1. Wait. Yeah, 16.1. Not bad. Scared myself there. Done easy. Now, we have... Oh, hang on a minute. Yeah, it's over 12, not over 14. I don't know where 14 came from. Please? Okay. Wow, that made a big difference, didn't it? 0.751. A huge difference. Okay. Now we have to work out the quartiles. So, again with the quartiles, I mean, hopefully you're okay with doing this. The median is the middle value. So you do n over 2, which is 12 over 2. So you're looking for the sixth value. Right? 1, 2, 3, 4, 5, 6. So 45.1. The lower quartile, so we call that Q1, is n over 4, which is going to be the third value. 1, 2, 3. So technically we'd need to put this in order first, but this is essentially what you do, right? You have the data in order and then you count them along. Okay? So ordering that data, bit tedious, not gonna lie, but we can do it. Okay. So depending on whether or not you want me to kind of do all of that, so actually kind of order the data. Doesn't look like anyone wants me to. Okay, so I think we'll call it there anyway. So again, next week we've got regression coming up. I'll see you.